Hello everyone, you're welcome to yet another video where we'll be doing something much more exciting. We're not doing further maths anymore. We're now going to a little bit of statistics. Let me scare you at the initial stage, and then after that, you'll see something much more interesting. If we go back to our old school mathematics or statistics, where we're being taught the concept of distribution, mean, median, mode, there were many things we were told back then. The easiest elements that we could compute were you are given a series and you are asked to choose the mode. You look at those numbers and the one that occurs the most, the one with the highest frequency is going to be your mode. You pick it and that's going to be easy. When you were told to calculate the median, you don't just go to the middle number and pick something there and say this is the median. The logic we had back then was you needed to first sort all the numbers in ascending order. Then you start moving one to the left, one to the right, till you get to the middlemost number. If you are lucky enough to have one number there, then that is your median. But if you are unlucky and you have two, then you find the average of those two, and that will be your median. And to get the mean of your set of numbers, it means you needed to add all the numbers. In fact, you still have to do it. You add all the numbers together and divide by the number of figures that you have in your distribution. That was the way we calculated the average or the mean. Later, we started learning things like standard deviation. The mean I spoke about is this X bar. Then we started learning about standard deviation, which is like how far apart are all the data points you have from the mean. This is the number of data points you have. You could use this formula and you get the standard deviation. A lot of people got scared about this. Oh, you needed to memorize. It was tough for many people. Yeah. If you are going beyond that and you're saying, oh, I have two data series, I want to know if they are correlated to each other or not. This is another statistical formula that you needed to memorize before you could solve the problem. And you compute multiple parameters, you plug them in here, you get your result. And then if your correlation result comes out as something close to one, the maximum is one, then it means you have a positively correlated, relationship between the two data series that you are measuring. Anything beyond 0.7 to 1 indicates strong positive correlation. Once you are between 0.4 and 0.69, then it means there's a sort of correlation, but it's not as strong as what you have from 0.7 through 1. And anything below 0.4 shows it's completely weak, and 0 means there is no correlation at all. And sometimes you may even see negative values being popped up on the screen. This is the formula we use to compute that. Most people don't like memorizing things like this. For those who are in the stock markets, they talk about constructing their portfolio in such a manner that the portfolio of stock is resilient. How do you go about doing that? You need to look at the series, the yields across different years for the different stocks that you are considering, and you check their covariance over the same timeline, and then don't choose stocks that are having similar relationships, something like a positive relationship or positive covariance value with one another when you compare all your stocks. Let's say you have five stock that you are looking at and you have their data for say the last 10 years. All of them must not be positively correlated to one another, because what it means is if all of them are positively correlated, then if there is a bust in the market, you are likely going to be impacted because all of them will behave the same way. So you want to diversify your portfolio in such a manner that if one stock misbehaves, there is still stability within your portfolio because all of them are not behaving exactly the same way. So you will come into the concept of covariance analysis. But do you need to remember this formula in 2024? The answer is no. because Python can do all of this for you if you know how to go about doing that. And that's exactly what I want to demystify in this set of demos that I'll be showing you. So let's go to the easiest one, mode. Let's say you've been given some numbers like this and you want to import, you want to deal with statistics operations. This time around, you are not importing maths, rather you are importing statistics. And once that line is written at the top, all of the knowledge based in statistics will be imported into your code and you can start making use of them. That's the major reason for having things being imported, intelligence being imported. So if I want to find the mode of this distribution, I know by manual inspection, 20 appears once, 35 appears once, 45 appears 3 times. There is no other number that appears more than once. So 45 will be my mode. I can verify by coming here to say statistics dot mode, and then I'll pass my data series, which will be the sales list that I have here. If I run this result, it says the mode of this distribution is 45, and that indeed is correct. Now we go to the next one, which is going to be the mean. Mean is supposed to sum all of them together and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I want to do this again, the knowledge is for me to say statistics dot find the mean of those sales numbers and display the result in the lower part of the screen that I have cleaned up, and it tells me the mean is 51.8. It's quick. I don't have to start doing the arithmetics of summing these numbers together and dividing by 10, which will take a much longer time. Python can do that, and that's the advantage of using computer programs. If I want to find the median, which is the middlemost number, the mathematics of this is that I must sort all of them and then pick the most middle number. By luck, they all look sorted except that 44 is here. So 44 will come to this place. And if you start knocking them off from one end and the other, you will arrive at what your middlemost number will be. But I don't want to do manual operations. That's why I have Python. So I'll go to statistics.median. I'll pass in my sales list and ask Python to give me the result, and it tells me the result is 45. That's the median of this. But there are instances in life when you need to do median high and median low. I looked this up when I first came across this function, and what it says is if you are looking for median high, it means when you start knocking numbers off your lists after sorting them from the beginning to the end. Let's try to sort this for sake of illustration. We'll do 44 here, not 444, just 44. That means we will delete it from here. 44, 45, yeah, it looks sorted. So if you come in here and you start saying take 20 off, take 99 off, take 78 off, take 35, take 44 off, take 57 off, take 45 off, take 51 off, then we are left with two numbers in the middle. Yeah, we are left with two numbers in the middle. So let's do something. I will change one of these to say 47. Okay, I'll change one of these to 47 and I'll copy this series and take it to median low. Yeah, sometimes you need to make some hot adjustment. Now, when you are doing this, you come to the middle, you find two numbers. Typically, median will mean add these two together and the average, you add them together, divide by 2, and that's going to give you the average. That should be like 46. But when you say median high, it says, oh, there are two numbers here. Which one is the higher of the two? Which one is the bigger of the two? Or which one is the larger of the two? Median low will give you the smaller of the two numbers. That's technically the way this works. So if I clean up my terminal and I want to sub that prop to, I'll say statistics median high first, and it will ask for my data series. And if I run this, I should get the result. Yeah, that's 47. That's what we were expecting. And if you go to this place and say statistics dot median low, we expect this result to be 45. That is correct. Yeah, that's true. So that's 45. So that's the way you can use median high and median low in this environment. I'll quickly go to the next demo, which has to do with harmonic mean. There's a math to this. Mean is just addition of all these numbers divided by 5. But harmonic mean will mean 5 divided by 1 over 4 plus 1 over 6 plus 1 over 8 plus 1 over 9 plus 1 over 10. Instead of I or anyone thinking of doing that manually, we will simply come in here and say harmonic mean of that series. Please give the result to us. We'll clean this place up. We execute this code and it tells us the result is 6.64. You can verify that manually and you will get exactly the same thing. So we quickly go to standard deviation. If you have this data series and you are being told to calculate the standard deviation, you simply say statistics.stdev and then you pass the sales parameter in there. You run the code, it will give you the result as 22.18. And if you are finding the variance, it's almost like one is the square root of the other. So I'll come in here and say statistics dot variance, and I'll pass the data series that I have in mind. Let me clean up my terminal so that the result is a lot clearer. So it gets 491 for us. So when you compare what you see in standard dev to what you see in variance, you'll see that the square root of variance is going to give you the standard deviation. So that's the way those two elements work here. And quickly we talk about correlation. Correlation is checking if two data series behave in the same manner. Same manner meaning if one is increasing, the other one is increasing. And when one is decreasing, the other one is also decreasing. It doesn't mean the decrease in one causes the decrease in other. We are just saying behaviorally, when one is going up, the other one is also going up. And when one is going down, the other one is going down. And we want to check how positively or negatively correlated the two data series are. So here we're trying to check if sales figures are positively correlated to the number of hours put in to actualize those sales. So you can come in and say statistics dot correlation, and it will ask you for the two data series that you are thinking of. So I'll say sales and hours, and I expect a decent result here. And it says they are strongly, almost perfectly correlated because this is 0.97. The maximum you can have is 1. But if you tweak the figures around a bit, you may not get that again. Even if I just say -4 here, that may be enough to change the narrative. And you can see now that the correlation has dropped significantly from 0.97 to 0.82. We need to be mindful of how to, calculate this. It's a very simple thing. Get your series right and then pass them into statistics.correlation. And for those who want to know how covariance works, it's similar to the way we dealt with correlation. Import statistics, get your values. The number of items must match, just like the same thing in correlation. You cannot have 5 items on the top series here and then have 4 in the lower series, or 6. They must match, otherwise there will be an error. So for instance, if I come in here and say statistics dot covariance of stock 1, compare it to stock 2. This will blow out in my face if I put 90 here because of what? They don't have the same number of elements. So you can see it says it requires that both inputs have the same number of data points, and that's why it's yelling at us here. So I'll remove the 90 that I put in. I'll clean my terminal and then run the code again, and it tells us this is the result you're going to have. Experts in statistics can now start telling you what is the significance of the covariance having this. It is higher than 1, it means something. When it is lower or negative, it means something else. So you can look up how this is interpreted in statistical world. So in this video, I've gone over my time. Just a quick summary. We've seen how you can handle basic statistical operations like mean, median, mode, median high, median low, how you can do standard deviation, variance, correlation, and covariance. At an advanced level, you should also be able to do regression, but I just don't want to bore you with that. Maybe later along the line, I'm going to demonstrate how you can do regression using the knowledge base that you have imported from statistics. If you find this video useful, subscribe to the channels, click on like, recommend to your friends, and then give me feedback on some of the exercises that you probably want me to demonstrate more to you. Thanks a lot for being part of this. I see you in the next recording. Bye.